Hello all, in this video we'll see how to handle multiple slaves with the DWIN master with the Modbus protocol over RS485. Here we have 5-inch 800 by 480 industrial grade display with the casing. On the top are the 2 pins for power source. At the bottom we can see A and B pins for RS485. We'll be implementing Modbus protocol over RS485 with this display where DWIN is configured as master. For first slave we have NSK RTU module, 8-channel relay module. This is also RS485 enabled. We have made a separate video on this NSK slave. The link is given in the description below. It has 4 analog inputs, 8 digital outputs, that is relay output, and 8 digital inputs. Power source is 12 volt for this. Separate power source is given. If you provide the 12 volt supply, you can see the display Modbus RTU. Slave ID is 1. You cannot change the slave ID of this NSK module, so we'll leave it as slave ID 1, and baud rate is 9600. So we have to configure all the devices with this same baud rate 9600. This is very important. In the DWIN master we have this A and B connections for RS485. The connection is simple between this slave and master. Connect the B to B and A to A. We can use twisted wires, and RS485 can support up to maximum 1 kilometer of length for data communication. For slave 2 and 3 we will be using PYMODSLAVE. This PYMODSLAVE is freeware built on Python and Qt, and it is very effective Modbus slave. We are using 2 instances of PYMODSLAVE. One is configured as slave ID 2 and other one is configured as slave ID 3. Now let us see the project file. We have 5 background images. On the first image, there is notice the naming of the images starting from 0. We use image animation icon on the first image, and delay time RTC millisecond is provided. After that time it will automatically land on the first page. That is the next page. That page is for slave 1, which is for NSK RTU. For read input registers we use data variables. 2 data variables we are using for getting the analog input values, and for write single coil we use bit icon and incremental adjustment. And for slave 2 PYMOD, that is slave 2 page 3, for read analog input we use data variables. For read holding registers we also use the same data variable, and for writing single holding registers we use data variable and data input combination, so that on clicking that keyboard will pop up, and if you can feed the value, decimal value, it will appear on the slave. Same way for multiple holding registers also we use the same combination. And the next page is for slave 3. This is for reading discrete output coils and reading discrete input contacts. Here you can see the VP address we are using is slightly different. That is bit definition area VP address we are using. In due course of the video we will explain that. And for discrete output and discrete input contacts we use bit icons. And for write single discrete coil we use bit icon and incremental adjustment combination, so that on changing that only same VP is used and only the bit varies. Accordingly the relay output will change in the slave. This is the DWIN_set folder. Let us see inside the DWIN_set we have .hzk, that is a font file, 0.hzk file, and most importantly the OS file. This is the OS bin file for master Modbus, and that baud rate is 9600 and UART5, as we are using RS485 for the display, 5-inch display we are using. You can download the Modbus master kernel file from the official website. The download link is given in the description below. Download it and then unzip it and select only the .bin file and paste it inside the DWIN_set folder of your project. And most importantly, the 22_config file. This, after saving and then generate, you have to copy this 22config.bin file to another place outside the DWIN_set, and then you can modify this using PSPad editor, hex editor. This is very important. You should not modify this within the DWIN_set. If you save and generate, then automatically it will go to default. And inside this bin file, you start the commands, that is the Modbus commands at 0x1c000. Now let us connect the DWIN master and test the NSK-RTO, that is the slave 1. You can see on the top of the DWIN display the analog values are displayed. This is for the analog inputs, the value from AN0. This is the value from AN0. If you vary the potentiometer, you can see the decimal value changing in the DWIN master. Same way the second potentiometer, this is connected to AN02, and the corresponding data variable changes in the master. For controlling the output, that is a discrete output, you can touch on the relay output that we have generated the bit icon. You touch on the on and off. Accordingly, the relay will be on and off in the NSK slave. So according to the configuration we have done in the 22_config.bin file, this corresponding relay is operating. Now let us see the 22config.bin file. We use PSPad editor to edit and go to 0x1c000 where we start the commands. The first command is for read input register, and the command is 0x04, and we have two VIP addresses, 1000 and 1001. Now let us write the command. The command starts with 5A, and 01 is the slave ID, 04 is the function code, and after that 01, which means 1 byte, which is 16 bits, which also represents only one VP, as we are going to write on one VP address 1000, and after that 50 is timeout 50 millisecond, and 01 is the mode. After that you have to mention the page ID, which is 0001, and VP address is 1000, and the slave address, that is slave address where we are going to get the data, which is 0000 from NSK-RTO. Same way for this next VP address 1001, and slave address is 0002. And for write single coil, the command function code is 0x05, and the VP address is slightly different. We have to use the bit definition area 2, and we are using VP address 0x111, and only the bit position changes. And in 22.bin file, as per the map, we have to use 0010, that is corresponding to the VP address. So the code is 5A01, 05 is the function code, and 01 is now number of bit. It is not byte or word, it is number of bits, and 60 is timeout, and 04 is the mode. After that, no definition, it is 0000, and we are using the VP address as 0010 as per the table, and VP address. After that, the slave address. Same way for the second coil, we use 0011, only the bit changes, 0011, 0012, 0013, and the slave ID also, the bit changes. This is the config file, and we tested the slave ID NSK-RTO according to this config.bin file. Now let us test the second slave. The connection between all the slaves are common, that is RS485 has two wires, A and B. So we are using RS485 to USB converters like this, which is connected to one port, and the second RS485 to USB to connected to second port. This A wires, all A wires are made common and all B wires are made common to slave 1. Slave 1 is actually the port, and we use this software slave. Now slave 1 is NSK RTU, and slave 2 is from PC, slave 3 is also from PC. This is the actual connection. All A connections common and all B connections common. Next we will see the slave 2, that is a PYMOD slave we are using for slave 2, and let us see the commands for this slave 2 for testing. Command 04, 03, 06 and 10. We will be using PYMOD slave and making one as slave 2 and another one as slave 3. Let us see the config.bin file. The command for analog input AI, that is the function code is 0x04, and we are using 3 VP addresses, 2000, 2001 and 2002, all contiguous. And let us see the command 5A. 02 is the slave ID, 04 is the function code, and 03 is 3 VP address, that is 3 words. 50 is timeout, 01 is mode, and which is page ID we have mentioned 0002. 2000 is the VP, and 0064 is the slave address. Same way for the next one, that is the 03, that is read holding registers. We use 2200 VP, and 006C is the slave address. And for the other write single holding register, that is AO 0x06, we use data variable as well as data input. 5A02, 06 is the function code, 01 one word, 50 timeout, 01 is the mode, and then the page ID. After that VP and the slave address. And for the multiple holding address, multiple holding registers, we use 0, that is 10 command. 5A 02 10. 03 is the number of VP addresses, that is total 3 addresses starting from 2600, and the starting address of slave is 0082. So this is the command for the slave 2. And before testing, let us connect the USB to RS485 to computer and node on the COM port, and let us configure the first PYMOD slave. Make the communication, that is a baud rate 9600, select it as slave ID 2. Starting address is 100, and number of registers may be 50. And same way for the slave ID 3 also, let us configure first, that is for select the COM port, related COM port, baud rate is 9600, slave ID is 3, and then connect that. So slave 2 and slave 3 we are using RS485 to USB and the communication port for communicating with PYMOD slave. Now let us test the slave 2. As we have seen the configuration bin file. Now let us test the slave 2. In the PYMOD slave, ensure that slave ID is 2, and then select AI, that is input register, and then start address is 100 as we have used 0064 hex, and notice the change in the master. You change the value at 100 location 100, 101 and 102, it will reflect in the master. Same way, select A0, that is the holding register, and at location 0x6C, that is 110 decimal we have used for the holding register. Change the value at 110 and 111, it will reflect in the master. The decimal value will reflect in the master. Next is 0x06 function code, write single holding register. Change to AO, that is holding register in slave ID 2 PYMOD, and location is decimal 120 as we use 0x78 hex. notice the location 120, and from master use the keypad pop-up keypad and change the value. It will reflect in the slave location 78. Same way for the multiple holding registers we are using 0x10 code, and notice the location 0082, that is 130 decimal. Feed in the value using pop-up keypad and it will reflect in the slave. So this is multiple holding register. Function code is 10. Next is the slave ID 3. Here for reading discrete output coil we use the VP address 0x101, which corresponds to 0010 as per the bit definition area. You check out the table here. Accordingly we have to use in the bin file. In the bin file, this is the command 5A, 03 is the slave ID and 01 is the function code. Next 01 is the 1 bit. It is not word, it is only 1 bit. And then 30 timeout and 01 mode, and 0003 is page ID, 0010 is the VP corresponding to the area 0x101, and 0064 is slave, that is the decimal 100. And we are using 4 bit icons and only the bit position varies. The VP is same, that is 0x101 we have used, and the bit position changes. The first bit 0, 1, 2 and 3 we have used. Same way for read discrete input contacts, the command is 0x02. We use the VP 0x101 and bit position changes, 0 bit and first bit. And in the function code you can see we have used 0020 as the VP, which corresponds to the bit definition area. For writing single discrete coil we use the second definition area VP address. 0x110 corresponds to 0000, and in the command 05 is function code, 01 is 1 bit and it is not word, it is very important, it is only 1 bit, and 60 is timeout, and we use the mode 04, after that 00 no definition, and the next 000 is the VP corresponding to 0x110 as per the table, and the slave address is 0079 in the hex. So let us test the slave ID 3. Open the PYMODSLAVE, so ensure that the slave ID is 3. Select DO coils and then the address is 100 decimal. Change from 0 to 1. You can see in the master the icon changes from the LED changes from off to on. Same way change the next location 101 decimal, the next icon changes. Like this we have used 4 icons. This is for DO coil. Next is read discrete input contact 0x02. Now select DI in slave, and then the decimal location is 110 and 111. From that location, this is discrete inputs, change from 0 to 1. You can see in the master the icon changes from off to on. This is 2 locations we have used, 110 and 111. And next change back to DO, that is the coils. Touch on the master from off to on. The value will reflect from 0 to 1 in the slave ID 3. So this is testing discrete output coils, single bits. Thank you for watching.